So this recording is on section 4.4, and we'll be talking about data subsetting. So many times we'll look at an entire data set and we'll graph it and we'll take a look at the visual and try to tell a story. In some cases, that's all we need. But in others, the data can be quite deceiving by looking at the entire data set. If there are very specific classes involved in the data that could affect the overall look of the data, but when subsetted into those classes, make a huge difference in our perception. Let me show you what I mean. The structure of a set of data is often exposed by using another variable to break the data into smaller groups, and this is called subsetting. A few years ago, a discrimination lawsuit was filed against the California Department of Developmental Services. The California DDS provides funding for developmentally disabled individuals within the state. The lawsuit claimed that the white non-Hispanics were receiving more funding than the Hispanics. If this was true, the DDS would face some serious legal and financial ramifications. So they hired several statisticians to analyze the data behind the issue. Were these claims of discrimination by the State Department actually true? So first we will create box plots to visualize how the lawsuit arose. We will look at the relationship between the ethnicity and the expenditure by plotting expenditure groups by the different ethnicities. So here we are. The x's in these box plots are the means, the averages, which remember is not part of the 5-number summary. The line that crosses the box itself is the median. And remember that when the mean is less than a smaller number, like this turquoise box here, is less than the median, we are talking about a skewed left data set where we have much lower, smaller numbers than we should, outliers on the lower end. And if we see that the mean, like in this baby blue box plot, is greater than the median, we know it's skewed right, meaning that there are much larger outlier expenditures. So we can see that the skewed left for Native Americans, skewed right for Asians, skewed right for African American. It's also skewed right for Hispanic, but we can see by the way that this particular box plot was created, which these dots here are outliers. And sometimes you can create box plots where the outliers are not included in the whisker. We look here at multi-race. We also have some outliers, but the majority of the spending looks very low. Native Hawaiian is an odd-looking box plot where the min and the max seems to be the same as the 25th and 75th percentile. This one's other, very skinny margin here. And the pink is the white non-Hispanic, skewed right, and definitely almost as high as Asian when it comes to expenditures. So if you were to look at these box plots and we're comparing them as races to the expenditures that have been used on these races, we would say that they definitely do not look like they have been dispersed evenly. It looks as if there are some races getting more money to help with certain things like education than other races. And if you look at these flattened box plots, it would look as if other multi-race and Hispanic are not getting the money that the rest of the ethnicities seem to be getting. If the data is examined on purely ethnic basis, then the figure that we just were looking at suggests that there is discrimination towards multiple different ethnic groups. But now we need to think about any variables that could be confounding in this picture. So recall, confounding variables are variables that directly affect our results of our study, but we weren't trying to test for those particular variables and how they affected our study. In many cases, confounding variables are so hidden that we don't even think about them, or we have not designed an experiment to eliminate or alleviate their effect on the results. The statisticians discovered that age played a massive role in the expenditure per person because more costs are associated with caring for an older developmentally disabled individual than a younger one. To account for the variation in expenditure between different ages, the statisticians decided to subset the whole data set into 6 different age groups and then examine the expenditure by ethnicity, but within each age group, so that we can compare how much it costs to fund a younger disabled versus an older disabled. And we should be able to see if now, by ethnicity, if there is an older population of a specific race that is getting more money than another race at the same age, then we can conclude that there is viability for a lawsuit. But when we take a look at these age groups, 0 to 5 years old, now all the box plots seem to be about the same. 6 to 12 years old, we see the same trend. 13 to 17, 18 to 21, we see that the box plots jump all together and all together in the older years. So, although as they get older, we do see a difference in the box plots themselves, and there are some that are much thinner than others, we can see that for the most part, the expenditures are equal across the board. So, to the surprise of many involved, the box plots were roughly the same for each ethnic group once age was considered. There was no evidence of discrimination found. The confounding variable age was accounted for. This is a classic example of Simpson's paradox, which states that the perceived association between two variables, ethnicity and expenditures per person, in this case, can be drastically affected by a third variable. And sometimes it's more than just a third. Sometimes it's a third, fourth, and fifth variable that need to be considered in order to really determine whether the comparisons are equal. When the data is partitioned by the third variable, age in our case, the alleged relationship may not exist or be just the opposite of what you were thinking. When analyzing the data, it is good to keep in mind Oscar Wilde's cautionary quote: "The truth is rarely pure and never simple." We must always be very cautious when contributing or attributing causation. And we talked about that before. Well, actually, we didn't talk about causation yet, but that is something that we will talk about, especially in an advanced stats class, and how, although variables can have a strong association, we have to be very, very careful to not imply that one of the variables caused the other one without really doing our research. All right, it was a smaller section, but that concludes 4.4.